Prosig DATS signal processing software and the Prosig P8000 data acquisition hardware to perform a microphone calibration. To begin with the microphone connected to channel 1, I'm just going to enter a signal name, which will be microphone. I'm going to set that signal to acquire, and we need to select a sample rate. In this case, a good acoustic sample rate is 44,100. It's always a good idea to set your target data file, even though in this particular tutorial we're not actually going to capture any data. It's a good idea to do it, and I'm just going to create a new folder on my desktop to save the data, should I capture any. And I'm going to give it a file name that's going to end in a number. And it's important to end the file name in a number so the software can automatically increment the data for you. I need to set the signal units. In this case, it's acoustics and pascals. And I need to set the transducer class. In this case, I'm using an IEP microphone. And it's important to notice that currently the sensitivity in the signal setup matrix is the default 1000 millivolts per Pascal. What I'm going to do now, just before we perform the calibration, is to save this signal setup matrix. And I'm going to call it setup. So that file's now saved, and if we need to come back to this setup, we have that ability. So what I'm going to do now is just arm the system and using the show signal review display page we can look at this particular channel, which is the microphone. We can see the minimum, mean, maximum dynamic RMS and a real-time display, which could be a frequency spectra, time series or orders are available. I'm going to select the calibration tab in the bottom left hand corner, and there are 3 types of calibration available: audio, tone and DC. We're going to use the audio calibration because it's a microphone, and our audio microphone calibrator has a level of 94 dBs, which is the default entered here. If you had a different calibrator, you would enter that value here. A microphone dB reference should always be this value here unless specified otherwise in the datasheet. In this particular case, we currently have no signal, a very low signal, which is shown in red, and that's because I've yet to turn on the calibrator, which if I now switch the calibrator on, we'll see almost immediately that the signal quality has now changed to green and good, and we have a acceptable kurtosis and skewness. If I use the calculate button in the bottom left hand corner, we'll see the calculated sensitivity is now 44.86137 millivolts per Pascal, and if I click on the use button, that value will have now been moved across into the signal setup matrix. If I go back and check, where before we had the default 1000 millivolts per Pascal, we now have the correct calibration for this particular microphone signal. And we also have a calibration date, so we are well aware of when that calibration took place. And we would now be free to perform a data capture or to save this setup and to use it again.